looking at this one, can anybody tell me where to start? I kind of stepped it up a couple levels.
I multiplied parentheses, the short term or the short route.
Okay. So we have parentheses in there. Anytime we see parentheses in a problem, we learn from our order of operations that it screams at us, do something here first. So we are going to have to start there first. So, come here. What we're going to do is we're going to split this on two sides. From the equal sign, we're going to look at the left side only. On that left side, we have this parentheses. Now, is there anything to do inside the parentheses? No, there's not. So the next question is there anything that needs to be done to the parentheses? And that answer, of course, is yes, being multiplied by 3. Now, one of the words that was out there was the word distribute. It's just multiplication, but distributing is just a process that allows us to shorten that up. So we just take the 3 times 7x, which is 21x. Then this is 3 times negative 5. Very good. So it's a negative 15. Now we still have the plus 2x and the minus 4 there. What are we going to do next? Okay, now we can combine things that have the same name. So we have 21x and we have 2x, which are going to make what? 23x. Then we have, this isn't a 15, it's a negative 15, and a negative 4 make negative 19. Good. On the other side of the equal sign, where would we start? 2 times the 3x, okay? We're starting with the parentheses again. Once again, there is nothing to do in the parentheses, so we have to ask what there is that we can do to the parentheses, and that is times 2. So 2 times 3x is 6x. 2 times negative 3, negative 6. The rest of the problem has not changed. Now what? Perfect. 9x plus 6x makes 15x. Negative 6 and positive 3 make negative 3. Very good. And for right now, that is as far as we know how to take that. So today's purpose is to go the next step and figure out how do we figure out the value of x once we've got it reduced down to that form. Before I go any further, does anybody have any questions off the homework from Tuesday?
One of my questions was said it was wrong, but it was right.
Okay.
Put it in divide, and it's
Fraction? Okay. Is that on the homework or on the quiz? On the homework, it won't matter. I'll make sure I fix that then when I put in the grade book. Anybody else have any questions off the homework? Okay. Did everybody get the quiz finished? Is there anybody that did not get the quiz finished? Oh, cool. That's a first that we got everybody through the first quiz without any problems. So I'm happy. Very happy. Okay then, well we can start in on new material right away then. Let's get back here. So, as we saw in that last problem, last class we looked at doing operations with our algebraic numbers and simplifying things. Now we can go ahead and look at the next step, where we have a variable that has a value, we just need to figure out what it is. So we're looking at things that looks like this. X equals 7. Obviously this is a really simple equation, But everything starts out like this. To understand how these equations work, we first have to understand this symbol right here. And of course, that symbol is the equal sign. What does it mean? That's a tough one, because we're used to just saying equal. Same as, yes. What it means is that what's on one side has exactly the same value as what's on the other side. In fact, we can think of this as a balanced scale. What's on one side exactly balances what's on the other side. Now, all equations start out in this form as a variable equals a number. And they're built up from there. But as we build them, we have to be careful to keep this scale balanced. So let's look at what we might do to build on to this equation. I mean, one thing we might do is add to it. So let's add 4. So if I add 4 to this side now becomes x plus 4. But as I said, we have to be very careful to keep this scale balanced. If I add 4 to one side, the scale is going to tip unless I add 4 to the other side. I have to do exactly the same thing to both sides of the equation, of the scale. So 7 plus 4 is 11. So we just built a slightly more complex equation. Now, if we are ever asked to solve, what it's asking us to do is take this equation apart and get it back to this form as a variable equals a number. In this case, x equals a number. Well, this equation was built by doing what? Adding 4. So how are we going to take it apart? Subtract 4. Very good. So if we subtract 4, it takes off that plus 4, putting us back at x. But again, to keep that scale balanced, what do we have to make sure we do? Subtract 4 on the other side. Do exactly the same thing to both sides. 11 minus 4 is 7. So we are back to x equals 7, which is where we started. We just solved that equation. Now this one was easy to solve because we built it. We saw it be built, so we knew how to take it apart. The complex part of these is to look at the equation and figure out how it was built. So let's start with some really simple ones. And figure it out. The way we go about that is we find the equal sign. And then we identify which side of the equal sign has the variable on it. In this case, it's over here. Once we've done that, we're looking just at that side of the equation with the variable on it. Over there, what is keeping my variable, in this case the y, from being by itself? A 2. And what operation is attaching that 2 to it? It is subtraction. So this equation was built by subtracting 2. How are we going to take it apart? Add 2 removes the subtracting 2. And like you said, we have to do it to both sides because we have to keep that equation, that scale, balanced. So over here, all that's left is the y. Here we have 13 plus 2 is 15. So y equals 15. Now, if we get to this point and we're not sure if we did it right, we can always go back to our original equation and put the number in and see if it works. If y equals 15, we should be able to put 15 in here and get a true statement. 15 minus 2 is 13. So we get the same value on both sides. So that's true. So we know 15 is the correct answer, or at least a correct answer. So on an equation like this, same thing. We find the equal sign. We identify where our variable is. So now on that side of the equation, what is keeping the variable from being by itself? The 7. What operation is attaching the 7? Multiplication. So this equation was built by multiplying the variable by 7. How are we going to take it apart? Divide by 7. Very good. Making sure we divide both sides by 7. So we're left with z over here. And on this side, 42 divided by 7 is 6. So z equals 6. Not all of our equations are going to look that simple. We might have something like this. Oh, what do I put in there? We'll do that. When we look at this, we want to figure out how this equation was built. In other words, what was done to the variable, in this case x, to build the equation. So, as always, we find our equal sign and we identify where the variable is. It's on this side of the equation. Now, on that side of the equation, what is keeping the variable from being by itself? There's the 7 and the 3. Okay. The 3 is multiplied. The 7 was subtracted. So if I'm looking at this, order of operations tells us what happens first. Addition or multiplication or subtraction. What happens first? Multiplication happens first. So when this equation was built, the variable x was first multiplied by 3, and then 7 was subtracted from it. Now, if you have ever put anything together, maybe you assemble a piece of furniture or a toy or anything, if you've just finished putting it together and you just put on that last piece, if you go to take it apart, what's going to be the first piece you take off? The last one you put on. So the first piece that comes off of this is the last piece that was put on. Subtracting 7 was the last piece that was put onto this. It has to be the first piece we take off. So how are we going to take that piece off? Add 7 to both sides. Very good. So that's gone, leaving us with 3x. 20 plus 7 is 27. Now what? Divide by 3. So x equals 27 divided by 3 is 9. And again, we can always go back to the original equation and double check. Let's put 9 in for x. So instead of 3x, this becomes 3 times 9 minus 7. Well, 3 times 9 is 27. Minus 7 is 20. We get the same value on both sides. So that equation is true. Any questions? Let's do another couple of those, and then I'll let you try some. So on this equation, same process. What has been done to build this equation? Here's our equal sign. There's the variable. How was this equation built? What was done to x to build this equation? It was multiplied by 5, and then 2 was added to it. So we're going to take this apart. The first piece we will take off is the adding 2, the last one put on. How do we take it off? Subtract 2. So we've got 55 equals, all that's left over here is 5x. And then divide by the 5. Not by 5x, just by the 5. Because the x has to stay there. So 55 divided by 5 is 11. And again, we can double check if we want to. 57 equals 5 times 11 instead of x. 5 times 11 is 55, plus 2 is 57. We get the same value on both sides. How are we doing? Good. So then, let's have you try one. I'll give you guys a couple minutes, see what you come up with on that one. So where do we start? Add 1. Okay? So 7y equals 42. And then we divide by 7. Good. y equals 6. To double check it, this would be 7 times 6 minus 1 equals 41. 7 times 6 is 42 minus 1 is 41. Looking at this one now, what's different about this one? The x, the variable, appears twice. Yeah, we find our equal sign. We go to identify where our variable is, and there's one on each side. We can't deal with two x's. We have to get rid of one. So what are we going to do? Yeah, we're literally going to just get rid of one. We're going to take it away, throw it away. Usually, we'll take the smaller of the two, which is going to be the 4x. Mathematically, how we take it away or get rid of it is subtracting 4x. It is now gone over here, leaving us with just 34 on that side. But remember, this is a balanced scale, so whatever we do to one side, we have to do to the other side. I have to take 4x from the left side as well. The only place I can subtract 4x from is 7x. 7x minus 4x is 3x. Now I still have the minus 2. And from this point, what do? Add 2 and divide by 3. X equals 12. Good. How about something like this? This one, the x still appears twice, but what's different? They're both on the same side. Do I have to take one of them away? Yeah, if I'm thinking this in terms of that balanced scale, if they're both on the same side, I can just take them and push them together into one big pile. And it will not change how my scale balances. So 5x and 2x make 7x. Plus 3 equals 52. Then what? Subtract 3. 7x equals 49. And then divide by 7. X equals 7. Any questions? So on this one, the x appears twice again. Am I going to combine them or am I going to take one away? I'm going to combine them. Why am I going to combine them? They're both on the same side of the equation. So I can just combine them. Now it's a little bit different this time because I have 6x and negative 4x make 2x. Plus 5 equals 31. What do I do from there? Subtract 5. 2x is 26. And then divide by 2. X equals 13. Any questions? How about here? X appears twice again. Am I going to subtract or combine? subtract. Which one am I going to subtract? Oh. In reality, it doesn't matter. I can subtract either one, but I always like to go after the smaller one because then I usually don't have to deal with negatives. So if I subtract 3x, it's gone here, leaving us 24. Then what? Subtract 3x from the 7x on the other side to get 4x minus 16. And then add 16. So I get 40 equals 4x. And then divide by 4. 10 equals x. We haven't done this for a couple problems, so let's do it. Let's double check this. So this is going to be 3 times 10 plus 24 equals 7 times 10 minus 16. 3 times 10 is 30, plus 24 is 54. 7 times 10 is 70, minus 16 is 54. So it reassures us that that answer is most likely correct. I'm going to have you try this one in your notes quick. You'll notice I put a little twist on this one. Can you tell me what it is? It's a negative 2x. Now, is this a combine or subtract? Well, kind of a subtract, but we're not going to subtract because it's negative, right? So it's a combine. Actually, it's one where we have to get rid of one of the variables rather than just subtract. We are going to get rid of the negative 2x. How are we going to get rid of it? Since it's negative, we're going to add 2x, leaving us with 29 over there. What do we have to do to the other side? Also add 2x. 10x and 2x make 12x plus 5. And then subtract 5. 12x equals 24. And then divide by 12. X equals 2. I'm going to trust at this point that you guys can plug them back in and double check it, so I'm not going to do that anymore. I'm going to have you guys try this one in your note. Again, if you get done before we go over it, feel free to plug it back in and double check it. Okay, so where do we start? Yes, we're going to combine the 5x and 2x, which make 7x. Good, so we got 7x, we still have the minus 7, which equals 56. And then add 7. Good. That's gone. We have 7x equals 63. And then divide by 7. So x equals 9. Okay, well, there's another little twist we can throw into this. Looks like that. What's different here? The parentheses. And anytime we see parentheses, it should scream at us, do something here first. And just like we talked about before, is there anything to do inside those parentheses? No. Is there anything that needs to be done to the parentheses? Distribute the 5. So 5 times 3x is 15x. You'll notice nothing over here changes. I'll just leave that 55 equals over there. What's next? 5 times negative 1 is negative 5. And then add 5 gives us 60, bless you, equals 15x. And then divide by 15. X equals 4. Tell me what to do. Okay, we got the parentheses. Again, there's nothing to do inside them, so we're going to multiply by the 7. So 7 times 2x is 14x. What's next? 7 times 5 is 35. So plus 35, since it's a positive 35. 91 doesn't change. And then subtract 35, giving us 14x equals 56. Good. And then divide by 14. X equals 4. Very good. And just like any others, we can go back here and plug this in. 7 times, parentheses, 2x becomes 2 times 4 plus 5. 2 times 4 is 8. Plus 5 is 13. And 7 times 13 is 91. So it works out. Try this one in your notes. Solve for x. What do we do first? 2 times 8x is 16x. And then 2 times positive 3 is a positive 6. Now we still have the 54 over here. Nothing's happened to that. Then what? Subtract 6. Give us 48 equals 16x. And then divide by 16, giving us 3 equals x. Perfect. Good deal. Let's step it up just a bit. Let's try this one, see what you come up with. Let's take a look and see what we got. Now, as we mentioned at the very beginning, we can look at this equal sign, and when we have stuff to combine like this, we can look at each side separately. So we're going to start just on the left side over here. And we're going to simplify or combine as much as we possibly can. What can we do over there? Distribute the 5 times 3x, which is 15x. And then 5 times negative 4 is negative 20. What else? We still have the plus 2x there. Good. Are we done? No, we still can. Perfect. 15x and 2x make 17x. And we still have the negative 20. Now we can move over to the other side. What are we going to do first there? Distribute. 2 times 5x is 10x. And then 2 times negative 11 is, okay, what else? We still have the 3x here, and this is a positive 10x, so I'm going to put a plus in front of it. Now what? 3x and 10x make 13x, and we still have the minus 22. And then we have an x on each side. We're going to get rid of the smaller one, which is the 13x. We're going to subtract it. Then what? Subtract it from the other side. Good. So now we have what over here? 4x, and we still have the minus 20. And equals negative 22. And then plus 20. 4x equals negative 2. Looks like I screwed up writing this problem, but that's okay. Divide by 4, we get x equals a negative 0.5 or a negative 1/2. How many people got that? Okay. I screwed up just a little bit on that problem. I wasn't ready for that to come out as a fraction yet, but that's okay. Okay, good. So anyway, a couple of things I want to review before we take our break. Since we came up with a negative there, I really want to review working with those integers. If I have something like this, 19 plus a negative 72, what's it going to come out to be? Negative. Are we going to add the values or subtract the values? Subtract. We've got a positive 19, negative 72. Since they go opposite directions, we subtract the values. So the difference between 19 and 72 is 53, so negative 53. So how about this one? Negative 12 goes that way. 41, same or opposite? Opposite, longer or shorter? Longer. So our answer is going to be positive. And we're going to be the difference between them. So 41 minus 12 is 29. How about negative 52 minus 17? Well, first thing, when we have negatives, we have integers, we never do subtraction. What are we going to change this to? Negative 52 plus a negative 17, which is negative 69. Good. We have 0, there's negative 52, negative 17 goes the same direction. Let's look at 37 minus a negative 45. Again, when we have integers, we try to avoid subtraction. So what are we going to do? We're going to change it to plus what? Positive 45, yeah. Remember, the subtraction always works on the number following, and it means add the opposite. So we're going to add the opposite of negative 45 is positive 45. So 37 plus 45 is pretty simple. It's just 82. What's this one going to be? Perfect. Negative 27 minus a negative becomes plus a positive 91, which turns out to be negative 27, positive 91 is the opposite direction and longer. Difference between 91 and 27 is 64. So positive 64. What's this going to be? Good. Negative 88. What's this one going to be? Negative 7. What's this one going to be? Negative 3. What's this one going to be? Negative 110. What's this one going to be? Positive or negative?
Positive.
Positive. 120 divided by 30 is 4. How about this one? It's a positive. 8 times 15 is 120. Have all of you tried to use the negative key on your calculator to do these? Have you been able to get them to work? Anybody that has problems with it or doesn't know how to use it? On yours? On that calculator, do you know where the negative key is? Okay. If you look down by the equal sign, right next to the equal sign, there should be a key that looks something like that. So to enter negative 8 times a negative 15, you're just going to use that key, 8 times that key and 15, and hit equals. And most of you, the key will work that way. If you have the one-line display Texas Instruments, it would be just the opposite of that. Your key is going to be like this. It's called the swap sign key. You'd actually have to enter the number first. So to enter negative 8, you'd have to type in the 8 and then press that key to make it negative. And then times 15 and press that key to make it negative. Either way, it better spit out a positive 120. If it doesn't, come talk to me and we'll take a look at it. Make sure you're doing it right. Okay, with that, I think it's time to take our break.